All right, let's keep rolling here. This is the second video in our calculus series review videos. All right, so we're just going to keep going. Sigma, whoops, I'm going to go over to, just going to go to blue. All right, so sigma n equals 1 to infinity of, I'm going to take 3k squared over, I guess I'll make that an n, 3n squared over n squared plus 4. So this one's similar to the previous ones. Hopefully you can see that. The easy way to do this is to use nth term. I'm going to say the limit as n goes to infinity of, and I'm just going to write the terms, 3n squared over n squared plus 4. Well, since they're polynomials of the same degree, 3n squared and then the n squared, I could just divide the coefficients. That's 3 over 1, which is 3. And all I say is that's not equal to 0. As long as it's not equal to 0, I know that the series that we're talking about diverges. So this diverges by nth term. All right, let's keep going. Let's go. Sigma n equals 1 to infinity of 2 over 3 to the n. You can do this one. You know how to do this one. We can write this as sigma n equals 1 to infinity of 2 times 1/3 to the n. And then it's in a geometric form. So this is geometric with an absolute value of r equal to 1/3, which is less than 1, which is what we're looking for. So therefore it converges by geometric series. Again, say instead of 1/3, say it was 4/3. Well, that would be bigger than 1 and it would diverge by geometric series. Alrighty, let's see what we got next. Okay. So, next one. Let's take sigma n equals 1 to infinity of -1 to the n plus 1 over n squared. A little weird, but hopefully you should say, oh, it's got the -1 in it. We know it alternates. So I'm going to say alternates. Because of that -1 to the n, it makes it positive, negative. And then I'm just going to look at the positive part of it. So I'm going to look at the limit as n goes to infinity of, I'm just going to take the positive part of it. So what would that be? 1 over n squared. Okay, because I just get rid of this -1 to the n plus 1. We don't need to worry about that when we're doing alternating series test. After we identify that's alternating, and I take what's left over. So that's 1 over n squared, and that's equal to 0. As long as this term, this limit right here is equal to 0, then we know that it converges by AST, alternating series test. All right, cool. Let's do another one. Sigma n equals 1 to infinity of 2 to the n over, I was about to write a k, n factorial. All right, so a kind of general rule, anytime we see a factorial, the ratio test is pretty likely to help us. So that's what we're going to go ahead and do here. Let's do the ratio test. Again, I set up a limit as n goes to infinity. This limit's going to be a little bit different. I'm going to write absolute value this time, a sub n plus 1 over a sub n. Now, this is a sub n, so when I do this out, I want to make sure to carry my limit notation. Absolute value. All right, so a sub n plus 1 is going to be 2 to the n plus 1 over n plus 1 factorial. And now I'm going to divide by a sub n, so I'm going to divide by this fraction. You should see pretty quickly, and you should be used to it, we're dividing by fractions, so we're going to copy dot flip, multiply by the reciprocal. So I'm going to write n factorial over 2 to the n. And that's equal to the limit as n goes to infinity, absolute value. I'm just going to reorder them. I like doing this so that we can make sure that we cancel the right things. 2 to the n plus 1 over 2 to the n times n factorial over n plus 1 factorial. So 2 to the n is going to divide into 2 to the n plus 1 and leave 1, 2 left at the end. So let me get a different color. So that tells me that all of those will cancel with all of those. So we're just left with the 2 in the top. And then I'll do a little bit of scratch work down here. Say I had 4 factorial over 5 factorial. Notice here I got n factorial over n plus 1 factorial. Similar here, I've got 4 and then 1 more than 4. That's 5. So if I write the 4 factorial out, it's 4 times 3 times 2 times 1. If I write the 5 factorial, it's 5 times 4 times 3 times 2 times 1. What I want you to see is that all these cancel and leave me with just that, which is just that. So similarly, so that's the one that is bigger, which would be this without the factorial. So that is what's going to be left over. So this is the limit as n goes to infinity of, what do we have? We have a 2 in the top, and then we get an n plus 1 in the bottom. Hopefully you see where that came from. I've probably gone into more depth about that in other places, but we're going to keep moving. So if I let n go to infinity, 2 over infinity plus 1, well, that goes to 2 over infinity, which is 0. I always want to see if it's less than 1 when we're doing the ratio test. So I say, therefore, converges by ratio test. Cool. All right. My next one. All right, we're going to go ahead and do 2 at the same time. I'm going to go sigma n equals 1 to infinity of 1 over 3 to the n. And I'm also going to do sigma n equals 1 to infinity of 1 over n cubed. All right, so what do we do here? One of them is geometric, and one of them is a p-series. Do you know which one is which? You should know. This one is geometric with absolute value of r equal 1/3 less than 1, therefore converges. And then this one is a p-series with p equal 3, which is greater than 1, and therefore that one converges. It's good to be able to distinguish between 3 to the n versus n cubed, or 4 to the n versus n to the 4th. All right, let's keep going. Let's do, I'm going to give you, we're going to go ahead. We're going to do sigma n equals 1 to infinity, negative 1 to the n over n cubed. So really similar to that previous one, except for it now alternates. So when I have an alternating series, it looks like a p-series, but it's not. When I have an alternating series like this, what I do is first I identify, all right, it alternates. So this does alternate, and the remaining piece after it alternates, I'm going to do AST, alternating series test. I'm just going to look at the limit as n goes to infinity of 1 over n cubed. And this one's really similar to one that we did earlier. And I do wind up getting 0. And therefore converges by AST. Anytime I have this limit equal to 0 of the remaining piece, then it converges by AST. So let's do another one that's going to use alternating series. Sigma n equals 1 to infinity of negative 1 to the n over root n. This is an alternating series, and what I'm going to do is look at the limit as n goes to infinity of, without the alternating piece, it's 1 over root n. And again, the square root of an infinitely large number is still an infinitely large number. So we're going to have an infinitely large number in the bottom, which is again going to make it go to 0. And therefore, this also converges by AST. All right, so part of the reason why I brought both these up is because A, we got to get good at alternating series, but B, I want to talk about what it means for something to converge absolutely versus conditionally. So this one converges absolutely, and this one converges, and when I say this one, I mean like this series and this series, conditionally. What I mean by that is, the easiest way that I like to think about this is 1 over n cubed, sigma n equals 1 to infinity of 1 over n cubed, would converge without the alternating series piece. So if I take the absolute value of this series and ignore the alternating piece, and just take 1 over n cubed, that series right there would still converge. The absolute value of this series converges, so we say it converges absolutely. This next one, if I were to look at sigma n equals 1 to infinity, and why is that previous one? Because it was a p series. We just did that earlier. If I just take the absolute value of this one without the alternating piece, I get 1 over root n. Well, that one diverges because it's a p series with p equal to half. So this thing converges conditionally. The way I like to think about it is it converges under the condition that it actually alternates. If I get rid of the alternating piece, it no longer converges. And that's something that the College Board will throw at us. Does it converge absolutely or conditionally? So hopefully you understand the difference between the two of those. I'm going to stop this video here, pick it up in the next one where we're going to get into some ratio test.